Welcome to this video. In this video, we are going to see catalysis. Catalysis is a process wherein a foreign substance present in a system where a chemical reaction is undergoing alters the rate of the reaction. That foreign substance is called catalyst. That catalyst may increase the speed of the reaction or it may retard the speed of the reaction. That process is called catalysis. Catalysts if they increase the speed, they are called positive catalysts. And if they retard the speed, they are called negative catalysts. Catalyst. The process is positive catalysis and negative catalysis. Let us see one or two examples for this. Potassium chlorate undergoes dissociation to give potassium chloride and oxygen. This reaction is speeded by the presence of manganese dioxide, which is a catalyst. Manganese dioxide does not get used up in the reaction. After the reaction, the same amount of manganese dioxide can be obtained back. This is a case of positive catalysis. This reaction you are familiar. In your smaller classes, you have learned this reaction for laboratory preparation of oxygen. Dissociation takes place when it is heated, when potassium chlorate is heated. Sulfur dioxide reacts with oxygen in the presence of nitric oxide as catalyst to produce sulfur trioxide. This reaction is made use of in lead chamber process for synthesis of sulfuric acid. The same reaction can proceed with another catalyst, vanadium pentoxide. This reaction is used in contact process for the synthesis of sulfuric acid. So these are three examples for positive catalysis, and these three are examples for positive catalysis. Now let us take up negative catalysis. In negative catalysis, the catalyst is a negative catalyst and it retards the reaction. Let us see a few examples. Hydrogen peroxide undergoes dissociation to produce water and oxygen. This results in wastage of hydrogen peroxide, which is a very useful reagent in the laboratory. So this has to be prevented. Dilute acids, say for example phosphoric acid, prevents this reaction. So this is a case of negative catalysis and this is a negative catalyst. Another example is chloroform. HCl3 reacts with oxygen to produce COCl2 and HCl. This substance is phosgene. It is a poison. CHCl3 was used as an anesthetic by medical practitioners especially surgeons in surgery, to relieve the patients from pain. Presence of phosgene can really be fatal. So this reaction can be prevented by a small amount of alcohol in the medium or in the system. So alcohol is another example for negative catalyst. This process is negative catalysis. What are catalytic promoters? Catalytic promoters are certain substances which, when present along with the catalyst, improves the activity of the catalyst. Let us see one example. In Haber process of synthesis of ammonia, nitrogen reacts with hydrogen to give ammonia. This reaction is catalyzed by iron. Presence of some amount of molybdenum enhances the activity of iron. Molybdenum acts on iron and increases the surface area of iron. The roughness of the surface of iron is increased. The free valencies of iron increase and more reactants can be converted to the product. So that is the activity of the promoter. Here molybdenum is the promoter, iron is the catalyst. Similarly, catalytic poisons. They are certain chemicals which, when present along with the catalyst, reduces or retards the reaction. We will take the same reaction. Nitrogen reacts with hydrogen to produce ammonia. Iron is the catalyst, but traces of hydrogen sulfide or carbon monoxide can retard the activity of the catalyst. Hence they are called catalytic poisons. These substances get attached to the surface of the catalyst, thereby consuming some free valencies. So the free valencies available for the reactants to get attached to the catalyst gets reduced. Therefore, the products become less. This process is, here this is gas, this is gas, this is a solid. Here this is a gas, again the catalyst is a gas. So this classification into positive catalysis and negative catalysis is on the basis of whether the catalyst increases the rate of the reaction or decreases the rate of the reaction. We can classify catalysis on another basis. The basis is the physical state of reactants and that of catalyst. If they are in the same phase, that is, the reactants and the catalyst are in the same phase, it is called homogeneous catalysis. If they are in different states, they are called heterogeneous catalysis. In this video, we will see one or two examples for homogeneous catalysis. Heterogeneous catalysis we will discuss in the next video. One example we have already seen, homogeneous. Another example is hydrolysis of methyl acetate, CH3, COOCH3, undergoes hydrolysis This is liquid, this is liquid, and this reaction is catalyzed by hydrochloric acid. Again liquid. What are the products? The products are ethanoic acid CH3COOH plus methanol alcohol. These are the two products. Here these reactants and the catalyst is in liquid state. So this is a case of homogeneous catalysis. Another is hydrolysis of sugar C12H22O11. Maybe aqueous. Undergoes hydrolysis, reaction with water, in the presence of sulfuric acid, dilute sulfuric acid. The products are C6H12O6 plus again C6H12O6. This is glucose. This is fructose. Their molecular formulae are the same. They are isomers, structural isomers. Structural formula alone differs. I hope you will be able to differentiate catalytic promoters, catalytic poisons, positive catalyst, negative catalyst, give examples for positive catalysis, negative catalysis, and reactions where promoters and poisons act. Hope you will be also able to understand homogeneous catalysis. The next we will take heterogeneous catalysis. We will discuss in the next video. Okay, thank you.